日本とここをつないでの、インターネットでつないでの記者会見になります。まず、日本側の方から始まります。
はい、それでは定刻となりましたので、本日の記者会見。
Now we are going to start the reporter briefing for Asteroid Explorer Hayabusa2 for the recollection of the recovery of the capsule at re-entries. My name is Mr. Kishi, the PR of JAXA. First of all, here, this is the Sagamihara Press Center, and also we have a Umera to Australia. I am going to introduce today's speakers and the presenters. The person at the JAXA and the Kuninaka Hitoshi, Director General, ISIS JAXA. And on the left side from you, and this is Mr. Professor Tsuda Yuichi, Project Manager of Hayabusa2 project team, ISIS JAXA. On the right side from you, Dr. Yoshikawa Makoto, Mission Manager of Hayabusa2 project team. And Yato Umera in Australia. And in Dr. Megan Clark, head of the Australian Space Agency. And another speaker is also from the Woomera, Australia, Fujimoto Masaki, Deputy Director General of JAXA, ISIS. Thank you. Now, first, Kuninaka, Director General of ISIS, will have a few words. My name is Kuninaka. I am a Director General of ISIS. This year, to 2020, actually, it's the 50th anniversary after the launch of Osumi, the first artificial satellite. And also, Sakigake was launched to Hare Comet. Actually, this is the 35th anniversary. The 2020 is this remarkable year. Actually, the deep space and planet exploration is very difficult, and we have made a lot of failures. For instance, Nozomi for Mars, we failed to reach it to Mars, and also Hayabusa. Actually, it didn't return as planned. And also Akatsuki, actually it took more than 5 years to reach it. But this was a really difficult area. However, Hayabusa2, this is done according to a timeline as expected, and it is now returning to the Earth. So this is 2020. We planned, and in December, and in 2 days, we are able to have it return. So we are actually the final stage. And if we can do that, we can be proud that we are capable of doing the exploration of deep space. And for the seniors who taught us, who instructed and guided us, I think we can show and demonstrate what we have done. And actually, that we have reached this stage, but we have still 2 more days left. And as a member of a Hayabusa team, I expect Hayabusa team will do it without any problem. Thank you for joining today. Next, from Umera, from Dr. Megan Clark, head Australian Space Agency, we will have a few words from her, and I would like to ask her to explain the situation, acceptance situation in Australia.
Thank you very much, and good morning to all of the guests listening.
おはようございます。そして皆様方どうもありがとうございます。
This is an extremely exciting and special event for Australia and for all of us here at Woomera.
もうここウーメラにおきましてもですね、オーストラリアにおきましてももう本当にこれは画期的、そしてワクワクするような機会となっております。
The purpose of the Australian Space Agency is to transform our space industry here in Australia, and we cannot do that without fantastic and wonderful international partnerships like with Japan.
で実際問題、そのオーストラリアにおきましてもスペースエージェンシーというものができまして、それがだんだんと進化をしているんですけれども、このような機会にですね、一緒に参加できる、協力できるというのはとても素晴らしいことだと思っております。
It is a real honor to welcome Dr. Masaki Fujimoto and his team, and to be able to do our small part to support the JAXA mission.
でそれから JAXA の方からは藤本さんにご参加いただきまして、いろんなことをまたサポートされておりますし、私たちもサポートしております。
Australia's long tradition of over 40 years of science and technology partnership with Japan was recently extended by Prime Minister Abe and Prime Minister Morrison recently, and we really appreciate the fact that we have now extended that cooperation in space.
昔からオーストラリアと日本というものはですね、この協力関係、特にサイエンススペースですねにおきましてはあったんですけども、今後ももっと私たちといたしましてもさらに日本とも関わって宇宙開発の方に目を向けていきたいと思っております。
I'm really pleased that we could support the JAXA team in 2 ways. One, providing the regulatory approval for the landing of the capsule here in Woomera, and also helping the JAXA team in coordinating through all of the Australian government agencies, and in particular making sure that this visit is COVID safe.
まずはですね、私どもが望みますのは、ウーメラの地にですね、JAXA のはやぶさからのカプセルが無事に着陸すること、そして全ての行動がですね、全ての計画が無事に終わるということを祈っております。
Fujimoto-san, it is a real honor to be able to support you, and we certainly look forward to deeper cooperation with Japan and JAXA in space.
藤本さん、JAXA の方とですね、ここで一緒に活動できる、そして日本のこのような活動をサポートできるというのは非常に名誉なことだと思っております。
ありがとうございます。
じゃあ、ありがとうございます、皆さん。
Dr. Clark, thank you very much. Now from the Hayabusa2 project team, and they will explain the preparatory status of the entry capsule. Now we would like to explain the current status of the Hayabusa2. Can you please look at the material at your hand? And first, the project manager, Mr. Tsuda, will explain to you. And actually, I would like to explain the explorer and the flighting status. And first of all, thank you very much for joining today. And I would like to start page 3.
First, okay, please see the page 3. And as for the actual status of the capsule for re-entry, and actually, TCM was down, the first down, and on December 1st, and actually this is a very fine adjustment. Actually, the 4.6 centimeters per second injection was done, and where the capsule should be landed, actually we changed it, and actually this 4.6 centimeter per second is comparing to the TCM3 was actually in order to move by 33 kilometers to southeast, and this is not just adjusting, but if the explorer is flying far away from the Earth, trajectory will be kind of different, and also trajectory accuracy will change. Therefore, making the best use of that, the landing operation could be much more accurate. Therefore, anyway, the collection team is waiting in Umela, and we have a purpose to change the landing target to land place so that our collection team can catch it very well. And currently, the range to receive the capsule is within this red circle, within this line, it has to land. And actually, this is a large area. However, the explorer itself is right before the re-entry. Actually, that it has been flying just within a very small tube or large tube, about 1 kilometer. Therefore, anyway, this time we are so much proud that the accuracy level is quite high, and actually this is because before the TCM3, we had a kind of control mode. For instance, injection or leakage of the gas, or the changing the attitude. Actually, we were very, very careful not to cause such kind of problems, and so far, anyway, we have been very careful. Therefore, all our efforts worked very well. That's why now we know where it is flying. However, we cannot control the ground weather like wind. Therefore, sometimes depending on the weather. Anyway, we believe that somewhere within this red circle, it should land. And next, please go to the page 4. And this is showing the operation after tomorrow. Actually, this is operation of the page 4 means for the December 5th. And actually, Hayabusa2 is working 24 hours. And actually, we are using the deep network of NASA. So anyway, it is tracked 24 hours. And the main members of the JAXA will get together before the 10:30 operation. Therefore, before 10 o'clock, so many people will come to the control room of JAXA. And we will declare the re-entry start at 10:30. Therefore, anyway, I'd like to explain only in Japanese time, and about 45 minutes at 11:45, the power source will be changed, switched to the internal ones. After the capsule is separated, the capsule will work by itself. Therefore, it must be switched to the internal battery. Therefore, after that, capsule itself can move by itself. And at 12:59, it will move to the kind of attitude to separate the capsule. And actually, this attitude is to maintain the correct attitude in order to enter the atmosphere. However, this is actually we said that the preparation attitude for the separation of the capsule, this is not the final one. And at this stage, actually, the easy to flight attitude and also easy to separate attitudes are both applied. And after that, again, the 10 degrees of the change is applied. And after that, final altitude will be obtained. And the Japanese said 1430, the capsule is planned to be separated from it, depending on that stage operation. Actually, of course, this is just a planning, but now we are planning like this. And as for if we confirm that capsule is separated right away, we will correct the altitude because the explorer has to escape from the Earth. Therefore, the TCM must be made. Therefore, the altitude has to be changed, nearly rotated about 180 degrees. And at the Japanese time, after 1530, for 3 times TCM 5 will be performed. And the first and the second and the third times, actually, the interval is about 30 minutes. And we will perform the 3 times TCM. And after that, the explorer itself will not fall down into the atmospheric of the Earth. Therefore, it will go back to the altitude in which it can have a cruising. And actually, maybe by that time, about 19 or 12, it should be done. And the reason why TC5 is doing that, actually, and this TCM must be done by the permission of the CRS. Actually, this is the government officials of the Australia, and the explorers in the capsule are flying over the area. The land is the planned land to the landing. However, first of all, the Hayabusa2 must escape from the actual landing area. Therefore, for the safety of the explorer, depending on such kind of safety, we will explain the conditions of the safety level of the Hayabusa, and we will get approval from the Australian government. However, we have to change the trajectory of the Hayabusa2 right after separating the capsule. Therefore, absolutely the permission must be obtained tomorrow, very soon. And after that, because according to the kind of plan that we already agreed, we will move on.
Next, page 5. This is what we will do on December 6th. After TCM5 is conducted, the explorer is at the 200 and 300 kilometers at the altitude. And actually, this depending on the trajectory, but basically it's around that. And when it is high speed at the 11 per second, it will do the so-called swing by. On the other hand, capsule, when passing the 120 kilometer at altitude, actually we have determined the trajectory. So the time is 2:28:27 JST. It's passing the 120 kilometers and the flight speed 11.6 kilometers per second. And then it is going to the dense atmospheric phase. And next one is a fireball phase. That means the capsule starts to flash because of the friction with the atmosphere. The time is 2:28:49 to 2:29:25. This is our expected time frame, but this depends on the weather, and actually it is gradually get heated. That means it is getting bright gradually. So actually we are not sure how it will look at. We do not know until we actually see it. But the period when you can see is very short period. So please make sure that you watch the sky in this specific time. And actually, in the fireball phase, the speed down to 3 kilometers per second. And even after the fireball phasing, it takes some time until it gets cooled down. So means you can see some trajectory, and it's getting slower and slower. And 100 meters per second, that means less than Mach 1, less than the sound speed. And from 2033 to 33, heat shield and parachute will deploy. These are done automatically. In the parachute phase, it will descend taking 20 minutes, and the landing time is 2:47 to 2:57 at one point, depending on the wind situation. So there is a big period. And after it landed, and parachute is detached. This is done automatically by the capsule. Because once the capsule gets landed, we do not want it to move any longer. So the parachute, if there is a parachute, it can move and fly away. And even after landing, the capsule moves and it emits some wave, waiting for someone discovers. We discovered it. And next, page 6. So this is a summary of the schedule. And basically, it's the same as the last briefing, but only the letter characters have been modified or made more precise, and we can enter the time in the unit of seconds. However, please understand there will be some error depending on weather. And these are the summary of preparation situation of the Explorer. So we have been prepared and we are fully ready. And also for the capsule, we have checked. And also we have power on. And that means power on for the capsule. And we have confirmed it works. But we need to switch to the internal power, and we need some explosives when it is at separation. Actually, this is only one-time chance. Whether it works or not, we have confirmed in the reliability test or the development before the launch. That means we need to do some action while watching monitoring the result. But we, the members, human beings, have already trained to do the right thing. So we are ready and we're waiting for tomorrow. And that's all from me. Next, regarding the preparation for capsule collection, the material is page 7. So the report is from Umera. Mr. Fujimoto, please begin. Yes, please look at page 7. Before that, please show us the fireball. We are doing this tomorrow. And page 7. So let me explain what we do in collecting capsule. And also a vehicle transmission is included. And so we are waiting at the landing site. And actually, as you can see, this is rehearsal flow, and we did rehearsal. First, next we made a measurement at the antenna station, and we made an estimation. And also we fly the helicopter. And after the helicopter flying, and we used a simulated capsule, and we collected the capsule and transport to the QLR. So this, we did the same thing as we will do in the actual collection. And also the time was also a midnight.
As a result, there are some problems, and actually I could find some more modified points, should be modified points. And actually that page 8 is showing the capsule correction training, and this one is the optical observation, and we check the brightness of the fireball, and we were transporting the collected sample from the helicopter to QLF. Actually, that is shown on the right side. Actually, the photo on the right is showing how we transport the collected sample. And after that, we are doing hand carrying with the capsule. And yeah, actually, even this kind of level, actually, we have been practicing, preparing for that. And anyway, in order to come to this phase, we had to do a lot of preparations, and of course there are so many support we gained, and to the support to the Sagamihara base and also Umura base, and thanks to lots of cooperation and support, now we have come to today. That's all from myself. Okay, from page 10, as for the Hayabusa2, after separating the capsule, anyway, the operation of Hayabusa2 will continue. And actually, I'd like to explain about the operation of Hayabusa2 after separation of the capsule. And this is after the capsule. Of course, we will the observation operation after the Earth swing by, and the purpose is that, of course, first of all, the calibration, because we know the Earth or the Moon. Therefore, anyway, with using the well-known information, we will check the calibration. And another one is bye-bye Earth events, and also would you like to check the cloud on top of the South Pole and North Pole? And also next one is the observation with the thermal infrared images. And as the observation of the Earth and the Moon will be done even after December 6th. And also, it will be utilized for the analysis of the Ryugu. And the next one is LIDARs, optical link experiment. And actually, about 5 years ago, it was done at Swing by. And as for the LIDAR, as you know, this is the kind of equipment to measure the distance between the explorer and the Earth, and using the laser beam. And I would like to use this opportunity for the simulation test. And after the return the Hayabusa2 to Earth, attempt will be made to send a laser beam from the ground station and receive it at the Hayabusa2, and then to send a laser beam from Hayabusa2 towards the ground and receive it at the ground station. And of course, we are aiming to development of laser-based technology in space exploration. And we have lots of cooperation, like National Institute of Information and Communication Technology, and ICT, and Australian, French, German observatory. Specifically, the Kogane National Institute of Information and Communication Technology Kogane Station in Japan, and the Mount Thurlow Observatory in Australia, and the Grasse Observatory in France, and the Wetzel Observatory in Germany. And actually, schedule is beginning immediately after returning to Earth from December 7th. And lastly, as for the schedule, always we try to let you know, but anyway, we will have the press conference after correcting the capsule at Sagamihara on December 6, 2020 from 16:30 and actually from 13:30 on December 5th, we will distribute on the internet for the capsule separation, and also on December 6th, actually the capsule will appear capsule fireable. Therefore, we would like to provide such internet distribution. And as for the reference on page 14, actually this is showing the AR observation of the entry fireball phase. And actually there is a kind of software, and everybody can use it. And I really want the Australian people to use it, but even in Japan, we can use AR application software. And this is just, the short, in Sagamihara. And if you use this application, depending on the brightness, depending on the altitude, you can know how different is the brightness. Therefore, if you are interested in, using this application, please download them here. And other than that, actually the final trajectory drawing, and also the extent bridges according to altitude is also something like that. Such kind of information is provided. And
Thank you very much, and we are very sorry and apologize for some trouble from the communication to Umera. We have a request to Umera people. If you make a question or make a comment, please make us say slowly and clearly, please. And from now on, we would like to move on to the question and answer session. And actually, we have three sites. So we start with Sagamihara, and next to Umera, and finally the online. And at Sagamihara, so I would like the reporter who have a question to raise a hand. And we have 2 stand microphones, and please use either one of them to make a question. And actually, we have a briefing at 3 sites, and we would like to make it very efficiently. So please start at Sagamihara. Yes, so as a person at the back who raised first. My name is Teranishi from NHK. I have a question to Mr. Tsuda. The day after tomorrow, the capsule is returning. And before that, tomorrow, you will separate and you will conduct TCM5. But there are various operations, and there are a few hurdles. But what do you think about that? Please let us share how you feel now. Thank you very much. Fortunately, the Explorer has been flying very smoothly, and actually, so far the operation has been very smooth and careful. That means members and the members in JAXA and outside JAXA and the people from Australia. First, I would like to extend my gratitude to all of them. And fortunately, we are now in a very good condition. And the last day, we will be very busy with a lot of operations, and we would like to do it one by one. And actually, we have prepared all necessary things, but finally, some of the Explorer operation we have not done it yet. I hope it works well, and I hope the weather in Australia is good. But I am very excited and looking forward to it. Next question, please. There's the gentleman in blue suit. My name is Tomi. Is a Nippon Industry newspaper. I have two questions. First question goes to Mr. Yoshikawa. After the capsule separation, how can the capturing is done? So how many images and where, what image can be taken? And another question is to Australia about the collection of capsules. Actually, where the collection team is waiting in Australia, and how do they move? How do they work after collection work starts? Thank you for questions. I would like to answer to the first question. So this is about the capturing of capsule, and in the page 6 of the capsule, we have a schedule list. And the time of the re-entry of atmosphere of the capsule is entered. And after the entry, the capsule starts flashing. So the attitude of the Hayabusa will change drastically, and the camera faces to the Earth, and then the capturing starts. But this is really difficult capturing, and I'm not sure, and I do not know what image we can take. We do not know until we do it. And as we are going to start and confirm the data within December 6th, and confirm the data. And from Australia, in Woomera, we 800 kilometers in east and west, and 500 kilometers in north and south. This is a desert. And actually, the capsule area is 100 by 300. It's an ellipse area. Actually, the a team of several members. We have 10 teams. So each of them is trying to catch the beacon signal, and some members are meeting the marine radar, and some are using camera, and each of them have its role. In total, we have in desert, we have 50 members working on the desert. So they are observing and using various methods. And also the data they observed are sent to the headquarters at Woomera. And this is like a headquarters, and they are using the satellite phone. And the data is transmitted, and the headquarters make analysis and identify where the capsule dropped. And after all the safety is confirmed, the helicopter flies to the site. That means we get permission. That means if there is a substance in the air, it might hit the helicopter. So first, we need to confirm that the capsule dropped on the Earth. And after this confirmation, we will fly helicopter and search for the capsule on the ground. Actually, this will be done when the sky is dark. And after the sun rises, the collection team moves. After sunrises, with some equipment, they go to the side of the capsule and collect the capsule. And the helicopter go back to the headquarters.
Therefore, if it goes very smoothly around noon, we really expect that we can collect the capsule. Then next person in the middle. Thank you very much. I'm Mr. Kaneki, and I'd like to ask you, three of you, Mr. Yoshinaka, Kuinaka, and Mr. Tsuda. Actually, all of you have served as a product manager of Hayabusa2, and now Hayabusa is returning to the Earth. And actually, the baton was succeeded to the next person. And I'd like to hear your kind of, the feeling, how you felt each stage or each phase. First of all, I'd like to say something. Well, actually, I was the manager of the Hayabusa2's startup phase. I was a team leader of Hayabusa, and again, I became a project manager later. But now I remember that it was about 15 years ago. Actually, the Hayabusa first had a problem, and after that, very soon, we started a discussion for the Hayabusa2, but actually we couldn't make a project very soon. Therefore, 15 years later, today, finally we could reach such a stage. So I'm so much impressed. And I was actually involved in the kind of start up of this project, and gradually the operation phase was proceeded, and gradually anyway the next people took over my job. And as for me, I was the product manager in especially the manufacturing phase. And actually, the budget was approved in 2011, and also, and therefore, the actuary, had only 3 years for the production or therefore, it was quite a severe condition for us in those days. However, actually, I was forced to, serve as a project manager. However, while, we are producing Hayabusa2, there are lots of problems. And, however, the R&D team and also with the cooperation with the private companies, we could overcome the hardships one after. However, actually, once we solved the problems, again we had another problem. Therefore, that 3.5 year was very severe days for us, I remember. However, the sample return project of Hayabusa2, what kind of project we can make, and the effect made by that, and also the significance made by that. As for that, everybody was sharing such kind of concept and also the desire for that, and such kind of motivation created, our unity among us. And actually, because we had a milestone for Hayabusa, that's why Hayabusa2 was established quite well, even in a very short timeline. And, up to the, lift off, we could reach very quickly. And some people are not really nicely say, Hayabusa. Actually, some people say that the Hayabusa had a kind of miracle in the space, but somebody said, the Hayabusa2 is going to have a miracle on the Earth. And I'm the third product manager. And before that, I was in charge of the R&D at the actual work floor. Therefore, as for the Explorer, I know the concept or content of the Explorer very well, technologically. And actually, I entered this JAXA, when the Hayabusa1 was launched. And after that, I have been involved in this project. In those days, I was somebody new here. Therefore, the operation there, and very quickly decision was made, and very quickly troubleshooting was done. However, still, even if we overcame a lot of problems, again and again we had a fresh problem. So what's next? How to do that? Anyway, I could have a good experiences of how to solve such kind of chain problems. And after that, the Hayabusa2, the project was established, and now I had a great position to utilize, my experiences. It was quite honor, and I was quite lucky as for Hayabusa2, not just development, but even after it was lifted off. Anyway, in Hayabusa1, we modified every part so that we will not have any problem in Hayabusa2. But anyway, such kind of effort must be reflected in our Hayabusa2 operation. There are so many things to do that. Therefore, what my job as a project manager is to do correctly in everything and in every phase. And however, actually, unfortunately, after Hayabusa arrived at Ryugu, Hayabusa2 made a great achievement, and it was even beyond our expectation. And Hayabusa2 is coming back to the Earth with such a smooth operation, and that is so much. I was impressed, and actually thanks to the cooperation and the unity of the team, and finally the Hayabusa2 is coming back to the Earth. And however, remember Hayabusa1 was so terribly, the work. However, anyway, we worked really hard to make a much better explorer than Hayabusa1. And anyway, we will let Hayabusa2 survive, and we'd like to move on to the next phase, the extended operation of Hayabusa2. Thank you very much.
Thank you very much. I have another question to Dr. Tsuda. I think there are a lot of Hayabusa2 fans. There are many fans for Hayabusa2. They are watching and monitoring. So please give a few words to them. Yeah, it is. We really thank those fans, but at the same time, we get nervous and we get tense because we have so many fans. And actually, before the launch, I think this is the first mission. So many fans are cheering and encouraging us. And I'm very happy or relieved that we can give and demonstrate some of the good results. And the day after tomorrow, Hayabusa2 will return, and that means the capsule will return. I think this is very rare and unprecedented case, even in the human history. So I hope those fans really will look at them and please recall what Hayabusa2 did, and also please expect and in the next future what kind of technology we can get and what kind of future we can get. I hope they have it. Thank you very much. I pray for the safe return, successful. Thank you. And because of the time limitation, we will have one more question from Sagamihara. And after that, we move on to the webinar and then move on to the online. And if there is time, we may go back to Sagamihara, but please understand. Then next question. As a person at the back, at the left side on the first line. This is Hayashi. I am a writer. I have a question to Dr. Tsuda. The other day at the briefing, you said the precision is required for returning. And in operation of capsule recovery, what do you think is the most critical issue? And actually, 220,000 kilometers return is very difficult. So what do you think is important, and how the team is like that, like now? Yes, first is the difficulty of re-entry operation. It's a separation at 220,000 kilometers. Actually, we have a different point, most difficult thing. In Explorer and another the substance flying with the space, but if there is no other extra force, we can predict how it is flying precisely. Therefore, we would like to separate as early as possible. So, however, if with the Explorer they have a jet, they can change altitude, but only a capsule, they have no drive, they can just ballistic fall. But the important thing is we have to separate after it is on the correct trajectory. Therefore, taking 2 weeks, we have made a precise measurement of the trajectory. That is just before the TCM3. That means 12 days before the entry, we have made an operation suppressing, stopping any disturbance. So even if the Explorer detects something unusual, we will not made into the stay hold mode. So we will move it in the safety mode without injecting a thruster. We were in such mode, and fortunately, we didn't find any abnormality. So during this period, the most issue is the return of the capsule, not survival of the Hayabusa. So the most critical thing is not to cause any disturbance. And thanks to that, we didn't jet any thruster. And thanks to this thrust, we made a good measurement of trajectory. And we have only did maneuver correction, trajectory correction, only a limited times, TCM3 and 4. And finally, just before the ballistic fall, we will separate. Actually, whether the distance is big or not, it doesn't matter for us. And actually, from now, the most critical point is from separation of capsule to TCM5. That means we have to conduct TCM5 after confirming that the capsule is detached, separated. We have only 1 hour to do so. And also, we have a distance of 220,000 kilometers. And we have first confirmed the capsule was detached. And also the mood of the project member, we are in a very good mood. Actually, we got a little bit nervous and tense, but we know each role. And that means in every hour or in every minute, we are doing what we should do. And we are in a very good mood. Thank you very much. Now we move on to the Umera side. And for the question and answers, we will have a sequential translation. First, we will receive the Japanese questions in Japanese. So if you have a question, please let Mr. Fujimoto know it.
I guess this is our turn. So if you have a question, please raise your hand. And when I pick you up for phone, she will carry mic to you. And please state your name, company, and then first we go for question in Japanese, and then next in English. で、then I would like to have a 日本語でご質問の方はまず、挙手をお願いいたします。Yes, please.
通信の偉大ですけど、すごくそうですね。オーストラリア入りするまでも中国に使っているので、あと今日、実際の時間前夜に言いますけれども、国立大の皆さん、指揮を挙げる効果明日に向けて、一つまではいないかもしれません。だから、そこで考えてます。
オーストラリアに入ってからですね、アデレードに2週間隔離がありました。で、この隔離の間をどう過ごすかっていうのは、もう出発する前からの課題だったんですけども、実は日本でも今度の問題があったので、これ、回収隊が一度に集まって仲良くならなかったんです。で、その中で2週間隔離で、オンラインではあったんですけども、この回収隊ということにかなり集中させる形で、いろんな班ごとに全体で会合を持って2週間の隔離で使えたと思います。その一方で2週間の隔離の間で、日本ではなかなか日本で全く報道されてないんですけど、南オーストラリア州がロックダウンするということがあって、その時はちょっとさすがに焦ったんですけども、南オーストラリア州のですかね、勇気ある決断という正しい決断だと思うんですけど、そのおかげで我々の回収事業を救われたと思うから、本当にそのことに関しては南オーストラリア州に感謝したいです。で、今日は全員前の日でお話でしたけども、実はリハーサルやった後に反省会みたいなのがありまして、リハーサルの結果がすごく良かったので、その反省会もここを修正すればできるよねっていう感じになっているので、特に何かするっていういい意味でそういう必要性は感じてないですね、正直。で、かつ回収の時間が変な時間なので、ちょっと男子方もできるだけ寝てるとか、そういうことをしたいと思うんですけども、回収が始まる事業が始まる直前にこういうところを気をつけようというそういった程度で済んだという感じです。
ありがとうございます。それでは、他にご質問がある方いらっしゃるでしょうか。はい、それでは、次の奥の方、お願いいたします。
はい、次ですね。はい、大丈夫ですか。はい。テロ修正と言い過ぎなことはかなり順調なというふうにおっしゃっています上で、こちら回収チームのオーストラリアの皆さんのですね、あまり問題がないようなというですね、それ以外にですね、想定外のことが必ず起きると思うんですけれども、回収の時にですね、今本当にあるとしたらどんな想定外のことが起きる可能性があるというお考えでしょうか。
津田さんからまずお答えになりますか。
Okay. Can you hear me? It says the microphone.
はい、大丈夫、聞こえてます。どうぞ。
Okay, we can listen to you. Thank you. If there is any unexpected problem, then from such a point of view, After the capsule is separated, TCM5 will be performed. I explained. However, if the capsule can't be separated, what to do? In such a case, anyway, we will send the separation command many times, as many as possible. And while we are doing that, we may not have time to perform the TCM5 so that Hayabusa can escape from the Earth sphere. And the TCM5 must be done after having the permission from the Australian government. Therefore, if we cannot make it, what to do is that the explorer and the capsule will re-enter the atmosphere. And after that, we will collect. Of course, it's a terrible decision, for us. Of course, we don't want to do that. But if the capsule can't be separated, we may have to make such a severe decision for us.
みたいなことが起きて、亡くなってしまったことはないかと思うんですけれども、本当に見つけられないという可能性はあるんでしょうか。
例えば考えると持ってきたとする。まず一番気になった結局コントロールできるものとコントロールできないものなんだと思うんです。でコントロールできないことは再現力をやっていくものです。今もですね、別にそれやってもしょうがないので1時間後に定義をチェックする、そういう精神状態になっているんですけども、今のところは手に良さそうなので、その意味では影響力がいいと思います。で、来週の言い方なんですけども、チャーシュートが開いてビーコン信号が出ているそうでます。で、一番いいのはビーコン信号が出れば、とにかくそれを追いかければいいということなので、カプセルが空中にあるうちは、その軌跡を追いかけますし、その着陸に推定してその警告が起こりますし、着地してからのカプセルがビーコン信号を数時間から続けますので、ヘリコプターはその信号を見ながら、最後は出てくるわけです。まず大体の着陸点のパイロットに変えますけども、パイロットそれをできるときにビーコンが出てれば、出てる信号を追いかける。最後は少し信号がなので、ここが出てるか出ないかが一つのポイントです。で、その次のポイントとして、パラシュートがいたら、信号出てないとしても、
So even if there is no beacons, if the parachute deploys, so we have a radar, and radar emits light beam, and the parachute reflects, and we can get the light. So if the parachute doesn't deploy, it's a kind of a hard landing. And we are doing the optical observation. And also we are trying to drone, and then the drone will try to find and take images, a lot of images, and make analysis, and try to find the capsule. So we are doing if some trouble happens. Thank you. Do you have any other questions? And we would like to receive And that's all from the Woomera. Thank you very much from the Woomera site. Next, we would like to move to the participants from the online meeting.
And actually, I'd like you to write down your questions to the chat line on our website. Well, so far, now we have one question on the chat. The Hoshinabi's Nakashima, actually, there is a question to the project manager. Please make a question, turning the microphone on. Nakamura, this is Nakamura.
よろしくお願いいたします。
Thank you very much. I have a question to Dr. Tsuda. Actually, now I'd like to talk about the worst case scenario. Sorry. And when the capsule can't be separated, and actually the capsule 2 may re-enter the atmosphere. And I'd like to know about the anti-impact capability of the capsule. What do you think about such kind of ones? Well, if the capsule separation is slow, but if you know that it is separated, there are so many phases after that. Therefore, even actually, the capsule itself is working very well, even if the timing was just delayed. Therefore, the sample inside the capsule should be no problem. There will be no damage as long as it can land on the Earth. However, if the separation can't be made, and if the reason of the inability of the separation is that, for instance, if the capsule itself doesn't work, a parachute can't be deployed. Therefore, it may crash to the ground. If such a situation happens, we cannot control anywhere anymore. And we had such kind of history in NASA. Of course, we are doing our best in order to save the capsule, but there is no 100% guarantee for every challenge. Thank you very much. And again, the question on the line, we'd like to receive questions. Then it seems there is no more question. Dale, would you like to go back to the Sagamigahara Hall? So are there anybody who have a further question? Okay, go ahead, please. I'm Hatanaka of Japan Broadcasting, and I'd like to ask Mr. Tsuda. I have two questions. Last time in the press reporting, actually, the targeting from 3.6 millimeters to the 10 kilometer is that that targeting the ladybug from 1 kilometer away. And well, first of all, my question is that are there any comparison, of such kind of targeting? And also, second one, after the capsule is separated, the parachute. As for the parachute, that there is no more autonomous control of the capsule because actually it takes a long time. Therefore, I'm a little worried about that point. First of all, to the first question before, well, actually, from about 3 million meters. Did I say so? No. I said that 3.6 million meters away to the 10 kilometer, and that is about 1 kilometer away to the small ladybug. Now I believe that somewhere on the ladybug should be successful, I think. However, now we found that our accuracy was by far better than that. The hearts of the ladybug, from 1 kilometer away, can be kind of targeted if if the ladybug has a heart, maybe we can target the heart of the ladybug, or even it's, and also the trajectory control. The capsule cannot make it, and once the capsule is separated, that will fly with that momentum when it was separated. Therefore, we are measuring how it will fly after separation. That is our measurement, and such measurements or the prediction was already done this morning, and that trajectory was already shown in the plan. The result is that the 33 kilometers was moved to southeast in that area, and actually on the ground there is a wind, and that today's wind is quite influential. Therefore, anyway, we are trying to target, so that the capsule can land in the middle of that circle. Okay, I wish a great luck for Hayabusa's or capsule's landing. Okay, next. The person in the third row from the deep.
Regarding the handover of the project managers, you mentioned before, this could be related. I have a question to Mr. Kuninaka. After the launch of Hayabusa2, and it was the project manager was succeeded to Mr. Tsuda, who was 39 years old. Then the mission started, and at the second touchdown, whether to implement touchdown or not, I think you have trouble, and you are considered whether or not to do that. You have such experience, including those experience, Mr. Kunisada. How do you feel? How do you think? How the team develops or team grows? Because the young people are the main members. Yes. Actually, for Hayabusa2, we have loaded many young people, particularly the exploration of the exploration. We loaded many young members. The purpose is we will have a new deep space exploration, such as MMX or SLIM, in order to implement that. I think we would like to use the Hayabusa2 as an OJT and have them experience, good experience for the future projects. That's why we assigned young people to this project. So I hope that the young people who experience at Hayabusa2 is a kind of a mid-career, and I hope they demonstrate their performance more in the next project. And JAXA is a national development corporation. So our target or major role is to develop explorer or machine. And today we are talking about the operation of the explorer. However, our major role work is to make something. That means when we launch a project, we have a lot of review. That means engineers need to undergo a lot of reviews. And when you undergo many reviews, that means your engineering value of the talent will be improved. And their job is to make some machine or explorer, but they first know what the space exploration is doing. So they first know what's the space exploration, and I think they will contribute to their own jobs later. Now, how do you think they grow or they develop themselves? And also, we had a big discussion at the second touchdown. We should take the full mark, or we should take the safe return, the satisfactory point at the 60 point or so. So that was a decision point in implementing the project. So we should not just do, we want to do exploration, but we need to be logical. We have to be theoretical, using a lot of grounds and evidence. Then we decided, we asked them to make a logical and quantitative analysis and make the project more precise and accurate. That's why we made a good decision for this. So how logical, how quantitative they made and they proceed. How they can predict, how can demonstrate the result. I think that's a lesson they learned a lot through this project. Thank you very much. And Mr. Tsuda, what do you think about Mr. Kudinaka's comment? Do you have any words? Yes. Actually, when we have to do an ultimate decision, and before the decision, the thorough examination is made involving the outsiders. If necessary, the correct decision should be made. That means correct decision is when we have to challenge, we will challenge, and we have to protect, we have to be conservative. Actually, at the decision, it was a really tough decision for me. But when we recall the entire project, but I think that JAXA made a good decision for reaching the goal. And so I am grateful for the support by Mr. Kuninaka. And then another question is about the material analysis. And after sample return, you will start the initial analysis, and you have 6 teams. That means how many universities and institutions will be involved in the sample analysis? Basically, so first we are grouping. So we will have first a joint team of initial analysis. And after the reporting out of the initial analysis, it's like a summary. So we are recruiting the research. And we would like to distribute particles and samples to promising researchers. So this is a kind of based on the offer our proposal. If we have a lot of samples, we would like to distribute it to everyone, but I think the volume of the sample is limited, so we would like to limit the number of the institutions, and we would like to distribute it to promising researchers and institutions. So according to this method, so rather than using or consuming all of the samples in a few years, but we would like to store 40% or 30% of the sample for the future. Because in a few years, maybe we will have a more advanced analyzers or some other equipment, it is for sure. So for believing the future technology of analysis, so we have a curation team, and we would like to store some samples.
And the same as you types of one sample, we have not consumed all the samples, and parts of the sample is stored for the future. That is our plan. Thank you very much. Okay, next. Okay, a person in the sweater in the front line. I'm a rewriter as Nafune. Thank you. As for the tomorrow's operation, maybe are you going to do something for the good luck? And how are you going to have tomorrow's operation? What kind of, the spirit do you have? Well, actually, good luck event or something like that? Well, first of all, there is a big dharma in the control room, and there is no eye on it. Therefore, first of all, anyway, before the operation, I would like to draw an eye on Dharma, and if possible, of course, I'd like to add one more eye, and especially in such a kind of a very big event, quite often we eat pork cutlets before, and this time we didn't have time to spare for that. Therefore, I don't know if we can have such a time for the good luck event. And also at the capsule collection stage, in the middle of the night, helicopter will go by identified the landfalls, but actually the reason of why are you going to collect the capsule after sunrise? It is because of the safety reason? Yes, that's right. For what we have been, Japanese thinking situation, actually, the desert is so wild that we cannot imagine that, and there are so many wild animals there in the middle of the night. Therefore, the situation in there is totally different from our areas in Japan. Therefore, moving in the middle of the night is so dangerous. Thank you very much. And next question will be made. The person in the second row. I'm Tsui of Kyoto Tsushin, and actually let me confirm about the capsule operation. And actually, the operation may be around 14:30 and something like that. And I'm understanding that the signal will be sent from the Earth to the capsule, and also the correct attitude is confirmed. And therefore, anyway, I'd like to know what is a kind of key point to say go for the operation. As for the capsule separation itself, in real time, actually it can't be separated if I push the button. And we will send a command, of that at certain time, the separation must be performed. And this capsule separation is not real time, but, for instance, 30 minutes later or 1 hour later, we set beforehand. And capsule separation itself have lots of stages of checkpoint, and we have to do it one by one. For instance, first of all, does it have a correct attitude without, showing that we cannot go to the next stage. And actually, the capsule is connected with umbilical. This is a cable, and the inside of the capsule can be seen from the signal from the explorer. However, when it is separated, such an umbilical is cut, and after that, it must be separated. Therefore, if the order is changed, even the capsule was separated, that such a line is connected. Therefore, we have to be very careful so that we can do one by one, step by step, and each step we have to judge if we can say go or no. And anyway, we are always judging. And another point is that from separation to TC5, you have only 1 hour. And as for the judging, if the separation is done well or not, well, how long does it have? And the separation itself must be found in 5 or 10 minutes. But sometimes it can take more time. But even if it takes more time, like 20 minutes, we have to judge very precisely. But in a good situation, I'm sure probably we can judge that it can be separated in 5 or 10 minutes. Then, we have been running out of the time. Therefore, the next question should be the last question in this Sagamihara. I'm Akiyama, freelance writer. Thank you very much. I have 2 questions. As for after the TCM5, Hayabusa2's plan, I have 2 questions. First of all, I'd like to ask Mr. Tsuda, after the TCM5, the imaging of the capsule, the significance of this imaging of capsule, for instance, Hayabusa2 worked really hard, and Hayabusa2 itself can confirm its own job, or of course, there should be a kind of technical solutions to do the imaging. And also another point is that liners, the beam link test, and what is the meaning of this experiment from Hayabusa2? The later beam is emitted from Hayabusa2 to the ground, and this is the flyby observation in the extended mission. That is your aim, and also on the contrary, from the ground to the Hayabusa2. Later beam will be sent to Hayabusa2, and this is for the future. Actually, such kind of technology can be led to the exploration for the Mars or some other planet in the future.
So I will answer to the first question. And the meaning, purpose of the capturing the capsule, separated capsule, is after the TCM is done, we thought that what can Hayabusa do after that? And we made a lot of ideas among them. It would be cool if we can take pictures from Hayabusa of capsule. So if we are asked if there is any scientific meaning, but actually this is not from the scientific news, but this is from what we can do, what Hayabusa can do after that. We know that this is a difficult job, and even if we can take images, how it will be like, or is it forecast? We do not know. But we have some experience, and the science team and the operation team will work hard, and it's a kind of a trial, an attempt to do something new. Then if we have such a chance, our members cannot stop not doing that. That means as long as there is no risk, and since this is after escaping the global software, actually the risk level is a little bit low, then we would like to challenge what we can do and more. And I'd like to answer about the LiDAR experiment. And this time is an experimental one. And the LiDAR for Hayabusa is aimed to measure the distance. And the asteroid is 20 kilometers at longest. But this time, whether they can receive light and they can measure a longer, much longer range using light, and we can make it apply it to deep space. So this is one of the challenge and just experiment. And about the optical communication, yes, it will possible for the future project. Hayabusa2 cannot do that. But in deep space, not only the electronic wave, radio wave, we would like to use optical communication. And in the Earth swing by in 2015, from 6 million kilometers, the radar is emitted from the ground, and Hayabusa2 received. And this experiment, radar 2 is down from the ground, and also another opposite direction from Hayabusa2 to ground station. We will do the both direction. In the optical communication experiment, it would be applied to the extended mission. Actually, these are not directly related to the extended mission, but this is kind of a possible technology, new technology that could be used in the future. Thank you very much. Now the time is running. We would like to conclude today's meeting. Finally, we would like to have a few words from Umera.
はい、意味もなく時間に1回天気をしてるわけですが、天気良さそうです。
Yeah, the weather will be fine.
以上です。
Thank you. Thank you for joining for a long time. I would like to extend our thanks to the people at Umera and those joining through online. And we would like to conclude the reporter meeting before the capsule recovery. Thank you for joining.